Alrighty, so yeah, I'm doing Wolf-Rayet stars, and they are a close cousin of Sophie's luminous blue variables. So Wolf-Rayet stars are massive stars at an advanced stage of evolution, and they're characterized by the fact that they're losing mass, up to 10 solar masses, through very strong radiatively driven stellar winds, which can actually reach speeds of up to 3 to 9 million kilometers an hour, which leaves behind a hydrogen-depleted helium core. They are also characterized by their unusual spectra, which have prominent broad emission lines for ionized helium, nitrogen, and carbon. Wolf-Rayet stars are population 1 stars. They have lifetimes of up to 1 million years, and eventually they explode as a type 1b or C supernova. The progenitors of Wolf-Rayet stars are very massive stars, greater than 25 solar masses, and more often than not, these tend to be blue supergiants. They can reach luminosities of up to 1 million solar luminosities, and their temperatures range from 20,000 to 210,000 Kelvin. So they are very massive, very luminous, and very hot. Wolf-Rayet stars are a spectral class of their own, and they are further divided into 3 subclasses. So WN stars, as the name suggests, are nitrogen dominant, and their spectra have been observed to have traces of carbon and helium. WC stars are carbon dominant, and again, their spectra have been observed to have traces of oxygen and some hydrogen, but no nitrogen. And then there's a third rarer subclass of Wolf-Rayet stars, WO, which have a carbon to oxygen ratio of less than 1. As an example, on the left here is a spectra of a WN6 star, and as you can see, it is helium dominated, and there's a little bit of a nitrogen peak right over there. And on the right here is a WC8 spectrum, and it is carbon dominated with no nitrogen at all. So on the AHR diagram, you can find Wolf-Rayet stars on the upper main sequence, right next to luminous blue variables. And in terms of variability, there isn't a consistent or general consensus. So for all of the Wolf-Rayet stars that have been observed, and if they show variability, the variability has been observed to have a period of ranging on the order of magnitude of hours to days. And some possible mechanisms which could explain any variability seen in different Wolf-Rayet stars they depend on which study you're looking at. So some studies think that the high temperatures cause changes in the spectra. That could be one reason for observed variability. The movement of stellar winds could cause variability. Non-radial oscillations and pulsational instabilities could be a cause or causes for observed variabilities. And in one paper, they suggested that unstable G modes being caused by the kappa mechanism could be another cause of the variability observed in their Wolf-Rayet star. So as a case study, Lefebvre et al. 2005 studied this Wolf-Rayet star 123. Here is the spectrum. And they didn't find a stable and consistent periodic signal over the 38 days that they consecutively observed it. However, they did find a relatively stable 9.8-hour period with about 0.2 magnitude variations. And they suggest that this relatively stable 9.8-hour period variability might be caused by pulsational instabilities. There are, of course, a lot more examples and studies done on Wolf-Rayet stars, but yeah, that's a basic overview.
Any questions?
Yep.
Do you know how common they are, how many stars are in that class?
Yeah. So there's, I think, a total of, about 500 stars discovered so far, most of them in the Milky Way. I was looking at a study which looked at some Wolf-Rayet stars in the Andromeda galaxy, M31. And there are also these things called Wolf-Rayet galaxies, that one, which are pretty much galaxies which have a very large population of Wolf-Rayet stars. Yeah, pretty sick.
So the variability, is that at the visual magnitude or is that within like the spectrum?
In the spectra mostly. Mostly in the spectra. Like most of the papers that I was looking at, they talked about the variability in the spectra, and that's like some theories as to what could cause that are those.